Hello, everybody. It's good to see everybody here. I've really enjoyed this conference, or Bayou on the Bayou, whatever you want to call it. My name is Max Wamsley. I'm a recently defended chemistry PhD student at Mississippi State University and CEO and founder of Claris Labs, which is a company based out of Mississippi State. So our technology addresses a lot of needs with diverse applications in many areas. However, through our more than 150 customer discovery interviews, we've identified a key beachhead market for oxidation testing and meat samples and pet food samples. Through this extensive customer discovery, we've identified several key pain points when it comes to pet food and meat sample oxidation testing, which is critical for determining the quality, the shelf life, and the taste of these specific samples. First, the efficiency is a major concern because these reliable tests can often take days to conduct, and you also need a bunch of expensive instrumentation to be able to get these reliable results. In addition, the reliability is also severely limited because you need a really skilled chemist to do these results. And also, a lot of the times you have to send these samples to chemistry laboratories, and the shipping time can cause sample degradation, which further impacts the reliability. In addition, since you need this chemistry laboratory to do testing, there's no portability that you can do for this specific analysis, so you can't do any on-site detection. And then, of course, because of all these results, the cost of these tests can be quite expensive, which also further impacts the testing methodology. So our testing technology is basically a portable instrument and a testing kit that can quantify the oxidation for meat samples, pet food samples, and meat-related pet food ingredients. The best part about this technology is a very simple three-step procedure that can quantify the oxidation in less than 10 minutes, which makes it really easy for industry leaders to train people to utilize this methodology, since you don't need a chemist to do these specific tests. This innovation is coming out of our research lab at Mississippi State, where we've developed an innovative methodology that utilizes an innovative, compact, patent-pending instrument that can measure the fluorescence at really low concentrations, and it's also portable, which allows us to do these tests on-site. Because of these specific factors, we're able to provide pet food manufacturers and meat manufacturers the ability to test for their specific ingredient quality as they're arriving at the facility. In addition, antioxidant companies also can benefit from this because they often do oxidation tests all the time, and the speed and reliability of the results is a big improvement on the current methodology. So based on our customer discovery, we've identified three key customer segments that we want to utilize this technology for. The first is antioxidant companies that commonly test for this oxidation in both pet food and human food. And this is proven evident by the letter of support we received from Kimin's technical director, which is a pet food antioxidant company that does both human and pet food testing. Utilizing these antioxidant companies, we want to spearhead the technology's implementation into pet food manufacturing by allowing a portable test that can test for both finished products and incoming ingredients. And then in addition, since this methodology has already been validated with meat samples, we also want to do meat testing with the meat industry to test for the quality. Now, you've been wondering, the meat industry is a lot bigger than the pet food industry, which is very true. But this testing is actually not conducted that often within the meat industry, which was quite surprising. And pet food has a much bigger need for this. And so that's why we're focusing on the pet food before we focus on the meat industry. And of course, this need is also evident by a letter of support that we received from the technical director at CalSec, which is a big ingredient supplier that does meat oxidation testing. So our market sizing is based on the current testing market within these industries, with our estimated serviceable obtainable market of the pet food industry being about 22.5 million if 10% of the market is obtained. However, this is also what we want to do through funding is establish this methodology across other samples. So we can do pet food, meats, nuts, and other samples, which has a total addressable market of around $2 billion. To kind of give an idea of the current market, a similar technology that's been unreliable, according to interviews, has a market revenue of around 6.5 million, but it's not suitable for meat testing or pet foods, and that kind of just gives us a better idea of the potential market for this. So our competitive edge compared to the competition is shown here in this little graph here with our next leading competitor, CDR Food Labs, not having reliable testing. It also can't do meat or pet foods, and it's also not portable. And then the next leading competitor is actually external testing laboratories that will do these oxidation tests for you. However, you have to wait a really long time to get these results. And then also, since you're sending the sample over, they can degrade and you have more unreliable analysis. So our business model is based on a one-time instrument sale to consumers, followed by recurring testing kit sales for oxidation testing. The price per unit of the instrument is estimated to be around $8,000, with 50% of that being revenue. And then the testing kits are estimated to be around $40, with 60 to 80% of that being profit, not revenue, excuse me. And then based on these analyses, we can see after 3 years, we projected to get around 22.5 million, with about 20 of that being yearly sales and testing kits. So our go-to-market approach is really highly dependent on really close, personable connections within the industry. And the reason for this is because we're a new technology that's needed, but not proven yet. And so we're really headstrong on doing conferences and tech expo participation to showcase this technology as well as make these connections. And then once we establish these connections, we want to build partnerships and collaboration to not only validate the methodology, but showcase it to the industry leaders. And of course, as they were talking about in the panel earlier, we're also going to do publications within the food industry to showcase it in our specific industries that we want to commercialize in. One thing I wanted to note is that we actually do have a collaboration right now with one of the world's largest antioxidant companies, Camlin Fine Sciences. We're working with Dr. Wamsley Nyake, who's the antioxidant scientific manager, and he's been giving us samples to kind of validate this methodology in the real world. And he's also agreed to be our industry advisor on an SBR Phase 1 grant. Shown here is our current team, and our ask, which I'll get to later, is really just building up this team so that we have a good, broad connection, as well as being able to implement this in other testing areas in the future. So I'm a recently defended PhD student that has extensive expertise in optical spectroscopy and instrumentation with 3 pending patents. My PhD advisor and the technical advisor is Dongmao Zhang with hundreds of publications on optical spectroscopy. Our industry advisor is Dr. Senanyake with a PhD in food science who has extensive expertise in oxidation. And then our current business advisor is Dr. John Burrs, who has 20 years of experience in strategic marketing and business development. Up to this point, we've been very, very, very headstrong on customer discovery. We actually got invited to do an SBR proposal, but we postponed it to do the I-Corps program. So we've participated in 2 regional and 1 national I-Corps. And right now we're finishing our SBR Phase 1 proposal, which will be submitted in March of this upcoming year. If we're awarded the SBIR Phase 1, we'll begin developing the prototype the following year and validate this technology and its use across the industry by collaborating with companies like Camlin Fine Sciences. By 2027, we expect to have a working prototype since it's a relatively simple design. And we will also try to get some SBR Phase 2 funding by the middle of 2027. This Phase 2 funding will be utilized to implement the testing methodology with other chemicals. So some things we're trying to look into is aflatoxin and mycotoxin based on our customer discovery. But we're also looking to other areas as well, such as fentanyl and opioids and things like that. By 2028, we hope to have AOAC accreditation, which will be really, really big for the company because there's no current methodology that can quantify oxidation testing rapidly and portably. So currently, we are in the very early stages of development. We're looking for, of course, safe funding or safe investing and seed funding, with our main goal right now being finding people that can be on our board of advisors and our committee to have bigger and more impactful results when it comes to our specific grants that we're going to apply for. And then, of course, once we get these methodologies established for oxidation, we want to have a methodology established for other chemicals as well. One key thing I wanted to note is that we have a bunch of other patents as well, but we don't have the time or resources to go about these. And one of them that we're really excited about is actually a patent pending cuvette and a microwell plate that can enhance the sensitivity of fluorescence. So another project in the future that we're looking to implement in our Phase 2 funding is implementing this to get more sensitive detection for proteins and things like that. Thank you all for your time, and if you have any questions or anything, I'll be happy to answer those, and you can also talk to me tonight at the little cocktail hour thing.
Thank you so much. Questions for Dr. Max at Mississippi State? So one thing I'm curious about is what's the benchmark in terms of how oxidation is measured at this stage?
Yeah, so the problem with oxidation testing now is that it reacts with everything, right? Because it has a bunch of oxygens, and those oxygens can react with whatever. And so the reason that our methodology is so innovative is because instead of waiting for that reaction to occur, it can react with anything during that time period, right? So what we do is we quantify within the first 5 minutes of the reaction, and we use a selective biomarker and a very high dilution factor to kind of negate the sample interferences within the sample. And then, as you can imagine, we want to implement the same methodology and instrument to a bunch of other selective biomarkers as well. So we're also looking into collaborations with people who've developed probes and things like that to utilize it for rapid on-site portable testing.
Great. Thank you. All right. Thank you so much. We appreciate your time.